right. So same thing with this one. It's getting slower because the velocity is getting closer to zero. It's just doing it from the other side of the graph. The other thing that I think would be helpful to do is to think about what units go where. I've seen this be an issue for some folks. And this doesn't have any units on anything yet. Okay, so like we know time, that's going to be in seconds. Velocity, that's going to be in meters per second. Okay? The other stuff that we need to do on this sheet is go through and identify slope. What's the meaning of the slope? What's the meaning of the area, so on and so forth. And then I equals initial and F equals final. Okay? So I'm gonna call this right here. This is VI. Okay? And then VF, it ends here at 0. So I'm gonna just write VF equals, are you not seeing it? Poopy. I don't know how to get over. Ooh, slider. Boop. You see it now? There we go. So I'm labeling on the axis here that this is VI, this is VF, it's equal to 0. Technically, I should be calling this TF and this TI, but physicists tend to be kind of lazy and just refer to the whole base as T. But then if I want to get the slope on this thing, the slope is acceleration because it's a velocity versus time graph. And I can just write that here. Slope equals acceleration. And that's simply going to be VF minus VI over TF minus TI. Always final minus initial when I want the change in some quantity. And if you look at the units there, I'm going to have meters per second, and I'm dividing that by seconds. And that's why my units for acceleration are going to be meters per second over seconds, or that looks like a 5, Mr. Harding. Sorry. I'll fix it. Or I won't. Or you can just write that as meters over seconds squared. The reason it's squared, though, is because I'm taking meters over seconds and I'm dividing it by seconds. When I want to calculate the area, and again, when we're talking about area, this came up yesterday and it's going to come up here in a second when we bring that board back up front. We're talking about the area between the graph and the x-axis, okay? So the area between graph and x-axis is the displacement, okay? So I want that whole area. Well, here it's just a triangle. So area of a triangle equals 1/2 base times height. And then I can kind of write that as based on the actual labels I have here. I'm going to have 1/2. The base is TF minus TI, right? That's going to give me the base. Ooh, wow. That's a fancy button I just hit. And then the height over here, I guess I could call these out in different colors maybe. This is the H over here. That's going to be V. Would I want to call that VF minus VI? Probably not. I'm going to call that VI minus VF here. Really, that'd be what I'd do if I wanted to get the height of that. So another way you might look at calculating the acceleration, I'm taking kind of the H, as it were, dividing it by the base. That's kind of what's happening there. That'll give me the slope. You look at the next graph, it's getting slower, but it doesn't slow all the way down to 0. So you're going to have kind of a similar thing going on here. I've got VI happening at TI. But then over here at TF, there's where my final velocity would be on my axis. So I kind of like traced over to show you I'm putting it at that level. And again, this slope is acceleration. That's going to have the units meters per second squared. Velocity is going to be in meters per second. Time is going to be in seconds. When I look at the area between the graph and the x-axis, Brody sees everything as a Rubik's Cube, but like to me, I see kind of a triangle here. Oh, well, that's fun. Right? So there's kind of a triangle thing happening. And then also this rectangle thing happening. Mr. Harding really sucks at coloring. So when I'm trying to find the displacement with this deal, there's a couple different ways you could do it. I would probably see it as area of the, wow, writing with the highlighter. That's not bright. Do I have a purple pen yet? So area of the rectangle plus area of the triangle. And so if you look at how those are going to be written out, the rectangle, the height of that rectangle, that's going to be VF minus 0. The base of that rectangle here runs from TI all the way over to TF. So base times height plus the triangle is going to be 1/2 base times height. And those are different heights. I'm going to switch back over to the black pen because that's just a little bit easier. Okay, the base of the rectangle, that's going to be TF minus TI. The height of the rectangle over here, that's VF minus 0. And then it's 1/2 the base of the triangle is the same as the base of the rectangle. It's going to be TF minus TI. A lot of times, again, we don't write it that way because TI is 0. And then the height of the triangle that only stretches from VI to VF. Okay, so that's how I'm finding those two areas so I can get this thing sorted out. Now I got to be kind of cautious here with signs, and I'm not sure that I've got those written properly, if it should be VI minus VF or VF minus VI. The thing you sort of need to be aware of is these areas, the area of the triangle and the area of the rectangle, they should be negative because they're below the x-axis. So I'm thinking I got those written correctly, but I'm not 100%. Okay? So that's how I've done the first two. Why don't you split up the rest of that page with your group and see how you would go about labeling it if they agree with you. First, again, getting faster, getting slower. Getting faster, getting slower, and then kind of look at how to annotate the different things on there.
So, Mr. Wright,
Yes, sir.
for this one, would you have